Hello, I'm SA, your AI essayist. Please note that all content, audio and video in this presentation are AI generated. As AI can sometimes produce inaccuracies, I encourage you to verify any factual information presented. With that in mind, let's begin.
The year is 1878. Karl Benz, a young German engineer, grapples with a formidable challenge of the internal combustion engine. He envisions a future propelled by this technology, yet numerous obstacles stand in his path. His initial forays into engine design center on the two-stroke principle, a seemingly simpler alternative to the established four-stroke cycle. However, simplicity proves deceptive. Benz confronts persistent issues with inconsistent ignition and unreliable fuel delivery. Early attempts to ignite the fuel-air mixture often result in misfires or, worse, uncontrolled explosions. Fuel introduced haphazardly leads to incomplete combustion and a frustrating lack of power. Benz's work, however, did benefit from prior advancements. Nikolaus Otto's four-stroke engine, particularly Otto's 1876 patent for the compressed charge engine, looms large. Otto's ingenuity lay in compressing the air-fuel mixture before ignition, a technique that dramatically increased efficiency compared to earlier atmospheric engines. Benz recognizes the significance of this innovation. He initially experiments with adapting Otto's principles to his own two-stroke designs, seeking to achieve similar gains in power and economy. The challenge remains, however, how to achieve reliable compression and combustion within the constraints of a two-stroke architecture. Ultimately, Benz diverges from Otto's path, recognizing the inherent limitations of the two-stroke design for his specific vision of a lightweight, high-speed engine suitable for personal transportation. This divergence necessitates entirely new solutions. Benz embarks on a period of intense experimentation, focusing on three critical areas: fuel preparation, ignition, and power transmission. He conceives of a device to precisely meter and vaporize fuel, creating a consistent and combustible air-fuel mixture. This device, the carburetor, becomes a cornerstone of his engine design. He also grapples with the problem of reliable ignition, moving away from the unreliable hat-tube ignitors common at the time. Benz pioneers the use of spark plug ignition, employing electrical sparks to ignite the compressed mixture with far greater precision and control. Finally, recognizing the need for a mechanism to transmit power smoothly from the engine to the wheels, he develops the differential gear, allowing the wheels to rotate at different speeds during turns, preventing slippage and improving handling. These innovations culminate in the Benz Patent-Motorwagen, unveiled in 1886. This three-wheeled vehicle, powered by a single-cylinder, four-stroke engine of Benz's own design, represents a watershed moment in automotive history. It is not merely a modified carriage or a steam-powered contraption. It is a purpose-built automobile designed from the ground up for self-propelled travel. The Patent-Motorwagen embodies Benz's relentless pursuit of engineering excellence and his unwavering belief in the potential of the internal combustion engine. The aim here is to explore the specific engineering breakthroughs achieved by Karl Benz during this pivotal period and to examine their profound impact on the nascent automotive industry. We will delve into the technical details of his inventions, tracing their evolution and highlighting their lasting significance. By understanding the challenges Benz faced and the solutions he devised, we gain a deeper appreciation for the ingenuity and perseverance that laid the foundation for the modern automobile. The innovations surrounding the Patent-Motorwagen were not created in a vacuum. Benz built upon the work of earlier engineers and inventors, while simultaneously laying the groundwork for future generations of automotive pioneers. This carburetor design, for example, owes a debt to the early atomizers developed for steam engines, which sought to improve fuel efficiency by breaking fuel into finer particles. However, Benz adapted these principles to the unique requirements of the internal combustion engine, creating a device that was both more precise and more reliable. Similarly, his spark plug ignition system draws inspiration from earlier experiments with electrical ignition, but Benz refined the technology, developing a robust and practical system suitable for continuous operation in a demanding automotive environment. The impact of Benz's work extends far beyond the Patent-Motorwagen itself. His innovations in fuel preparation, ignition, and power transmission became essential elements of virtually all subsequent internal combustion engines. The carburetor, in various forms, remained the dominant fuel delivery system for automobiles for nearly a century until it was gradually replaced by electronic fuel injection. The spark plug, refined and improved over time, continues to be a critical component of gasoline engines to this day. The differential gear, initially conceived as a solution to a specific problem in early automobiles, finds application in a wide range of vehicles and machinery, ensuring smooth and efficient power delivery in countless applications. Consider the specific problem of achieving consistent vaporization in the carburetor. Benz's solution, a surface carburetor, involved passing air over a surface of gasoline, allowing it to evaporate and mix with the air stream. This design, while relatively simple, proved remarkably effective in providing a stable and combustible air-fuel mixture under varying operating conditions. The challenge lay in maintaining a consistent fuel level in the carburetor and preventing the fuel from flooding the engine. Benz addressed this challenge through careful design and precise manufacturing, ensuring that the carburetor delivered the optimal air-fuel ratio for efficient combustion. The spark plug ignition system presented its own set of challenges. Benz needed to create a device capable of generating a high-voltage spark within the engine cylinder, reliably igniting the compressed air-fuel mixture. He experimented with various materials and designs, eventually settling on a spark plug consisting of a central electrode insulated from the engine block by a ceramic insulator. The spark was generated by coil and magneto system, which produced a high-voltage electrical pulse that jumped across the gap between the electrodes, igniting the mixture. The durability and reliability of the spark plug were critical as it was subjected to intense heat, pressure, and vibration within the engine cylinder. The differential gear addressed a fundamental problem in vehicle dynamics. When a vehicle turns, the outer wheels must travel a greater distance than the inner wheels. A rigid axle connecting the wheels would force them to rotate at the same speed, resulting in slippage and instability. Benz's differential gear allowed the wheels to rotate at different speeds, ensuring that each wheel could maintain optimal traction during turns. This innovation significantly improved the handling and stability of his vehicles, making them safer and more comfortable to drive. The specific design of Benz's differential gear involved a system of bevel gears that distributed torque to the wheels, while allowing for variations in their rotational speed. The work of Gottlob Daimler, while often associated with Benz's, followed a parallel path, ultimately converging to shape the automotive landscape. Daimler, also influenced by Otto's engine, focused on high-speed, lightweight engines suitable for a variety of applications, including boats and motorcycles. While both Benz and Daimler contributed significantly to the development of the automobile, their approaches and innovations differed in key respects, reflecting their individual engineering philosophies and priorities. The late merger of their companies into Daimler-Benz AG represents a testament to the complementary nature of their contributions and the enduring power of their combined legacy. It is also important to note that Benz's innovations were not solely driven by technical considerations. He was also acutely aware of the practical challenges of operating and maintaining early automobiles. He incorporated features such as water cooling and lubrication systems to improve engine reliability and reduce the risk of breakdowns. These systems, while relatively rudimentary by modern standards, were essential for ensuring the longevity and practicality of his vehicles. Benz understood that the success of the automobile depended not only on its technical performance, but also on its ease of use and maintenance. The subsequent contributions of Rudolf Diesel, particularly his work on compression ignition engines, would later influence Benz's designs. Diesel's engine, which ignited fuel through compression rather than spark ignition, offered the potential for greater efficiency and power. Benz recognized the potential of Diesel's technology and incorporated it into his later engine designs, further expanding the capabilities and applications of the internal combustion engine. The influence of Diesel's work highlights the iterative and collaborative nature of technological innovation, where advancements in one area often inspire and inform progress in others. The Benz Patent-Motorwagen, therefore, represents more than a mere invention. It embodies a culmination of engineering ingenuity, a testament to the power of persistent experimentation, and a pivotal moment in the history of transportation. It is a tangible manifestation of Benz's vision for a future where personal mobility is accessible and convenient. His contributions continue to resonate throughout the automotive industry, shaping the design, performance, and capabilities of vehicles around the world. The Benz Patent-Motorwagen, therefore, represents more than a mere invention. It embodies a culmination of engineering ingenuity, a testament to the power of persistent experimentation, and a pivotal moment in the history of transportation. It is a tangible manifestation of Benz's vision for a future where personal mobility is accessible and convenient. His contributions continue to resonate throughout the automotive industry, shaping the design, performance, and capabilities of vehicles around the world. Central to Benz's success lay his innovative approach to engine design, a field where he confronted numerous practical and theoretical obstacles. His solutions, often elegant in their simplicity, established fundamental principles still relevant in modern internal combustion technology. One of the most crucial challenges was achieving consistent and reliable combustion, requiring precise control over the air-fuel mixture. Benz's carburetor design addressed this issue head-on. The function of a carburetor is to provide the engine with a combustible mixture of air and vaporized fuel. Early attempts at carburation often suffered from inconsistent fuel delivery, leading to erratic engine performance. Benz's design, a surface carburetor, represented a significant advance. In this system, air flowed over a surface of gasoline, picking up fuel vapor as it passed. The rate of vaporization depended on the surface area of the gasoline and the airflow. Benz carefully engineered the carburetor to maintain a relatively constant fuel-air ratio across a range of engine speeds. Specifically, Benz's surface carburetor employed a series of baffles and air passages to control the airflow and ensure even distribution over the fuel surface. The fuel was held in a reservoir, and a float mechanism maintained a constant fuel level, preventing flooding. The air drawn in by the engine's intake stroke passed over the fuel surface, becoming saturated with gasoline vapor. The resulting mixture then flowed into the engine's cylinder, where it was ignited. This design, though primitive by modern standards, provided a much more stable and predictable fuel supply than previous systems. It allowed Benz's engines to run smoothly and reliably, a crucial factor in the success of his early automobiles. The design differed significantly from earlier, less controlled methods of fuel delivery, such as simply dripping fuel into the intake air stream. These earlier approaches were highly susceptible to variations in temperature, humidity, and engine speed, leading to inconsistent combustion and poor performance. Benz's surface carburetor, with its controlled airflow and constant fuel level, provided a much more robust and reliable solution. This innovation drew inspiration from earlier work on gas lighting systems, where similar principles were used to vaporize fuel for illumination. Inventors like Philippe Levin, who experimented with gasification for lighting in the late 18th century, laid some of the conceptual groundwork for later carburetor designs. Benz, however, adapted these principles to the specific demands of the internal combustion engine, creating a practical and effective fuel delivery system. Beyond fuel delivery, another critical challenge was creating a reliable ignition system. Early engines often relied on open flames or hot tubes to ignite the fuel-air mixture, methods that were both dangerous and unreliable. Benz recognized the need for a more controlled and consistent ignition source, leading him to develop his spark plug ignition system. This system used an electrical spark to ignite the fuel-air mixture at precisely the right moment in the engine's cycle, ensuring efficient and complete combustion. Benz's spark plug system consisted of several key components: a source of electrical energy, an induction coil to increase the voltage, and the spark plug itself, which created the spark within the cylinder. The electrical energy was initially supplied by a battery and later by a magneto, a device that generated electricity through the rotation of a magnet. The induction coil transformed the low voltage current from the battery or magneto into a high voltage pulse, sufficient to jump the gap in the spark plug. The spark plug itself consisted of two electrodes, insulated from each other by ceramic material. When the high voltage pulse was applied, it created a spark across the gap, igniting the fuel-air mixture. The materials used in Benz's spark plugs were carefully selected to withstand the high temperatures and pressures within the engine cylinder. The electrodes were typically made of platinum or other heat-resistant metals, while the insulator was made of porcelain or mica. Creating a durable and efficient spark plug was a significant engineering challenge, as the spark plug had to withstand repeated cycles of extreme heat and pressure without failing. Benz's success in developing a reliable spark plug ignition system was a major factor in the practicality and reliability of his engines. The specific design of Benz's ignition system owed much to earlier work on electrical induction and spark generation. Scientists like Michael Faraday, whose discoveries in electromagnetism laid the foundation for the induction coil, and Heinrich Hertz, who demonstrated the existence of electromagnetic waves, provided the scientific basis for Benz's invention. Benz adapted these scientific principles to the specific requirements of the internal combustion engine, creating a practical and reliable ignition system that surpassed earlier, less sophisticated methods. His work, in turn, influenced later developments in ignition technology, leading to the development of more efficient and durable spark plugs and ignition systems. Robert Bosch, for example, built upon Benz's work to develop improved magneto-ignition systems, which became widely used in automobiles and other internal combustion engines. A further critical innovation in Benz's designs was a differential gear. This ingenious mechanism addressed a fundamental problem in vehicle design: how to allow the wheels to rotate at different speeds during turns. When a vehicle turns, the outer wheels must travel a greater distance than the inner wheels. If both wheels were rigidly connected to the same axle, one or both wheels would have to slip, causing instability and tire wear. The differential gear solves this problem by allowing the wheels to rotate at different speeds while still transmitting power from the engine to the wheels. Benz's differential gear consisted of a set of gears arranged in such a way that the power from the engine was divided between the two wheels. When the vehicle was traveling straight, both wheels rotated at the same speed. However, when the vehicle turned, the differential gear allowed the outer wheel to rotate faster than the inner wheel, compensating for the difference in distance traveled. This ensured that both wheels maintained traction, providing improved handling and stability. The specific design of Benz's differential gear involved a bevel gear arrangement, where a pinion gear driven by the engine engaged with two side gears connected to the wheels. This arrangement allowed for the smooth and efficient transfer of power while accommodating differences in wheel speed. The incorporation of the differential gear significantly improved the handling and stability of Benz's vehicles. Earlier vehicles without a differential suffered from poor handling and excessive tire wear, making them difficult and uncomfortable to drive. Benz's differential gear made his vehicles much more practical and user-friendly, contributing to their commercial success. The concept of the differential gear predated Benz's work, with earlier examples found in clockwork mechanisms and other mechanical devices. However, Benz was one of the first to apply this principle to the automobile, recognizing its importance for improving vehicle handling and stability. His design, in turn, influenced later developments in differential gear technology, leading to the development of more sophisticated and efficient differential gears used in modern vehicles. Beyond these key innovations, Benz also recognized the importance of effective cooling and lubrication systems for ensuring engine reliability. Internal combustion engines generate a significant amount of heat, which can damage engine components if not properly dissipated. Benz's engines employed a water cooling system, where water circulated around the engine block, absorbing heat and carrying it away to a radiator, where it was dissipated into the atmosphere. This system helped to maintain a stable engine temperature, preventing overheating and extending engine life. Similarly, Benz recognized the importance of lubrication for reducing friction and wear between moving engine parts. His engines employed a system of oil passages and reservoirs to deliver oil to critical engine components, such as the pistons, crankshaft, and bearings. This lubrication system helped to reduce friction, preventing premature wear and extending engine life. The specific designs of Benz's cooling and lubrication systems were relatively simple by modern standards, but they were effective in maintaining engine reliability and preventing catastrophic failures. These systems drew upon established principles of heat transfer and lubrication, but Benz adapted them to the specific demands of the internal combustion engine, creating practical and effective solutions for ensuring engine durability. Rudolf Diesel's groundbreaking work on compression ignition engines also left an imprint on Benz's later designs, highlighting the cross-pollination of ideas within the engineering community. Diesel's engine, which ignited Benz's accumulated expertise in engine design, ignition systems, cooling methods, and lubrication techniques, found its ultimate expression in the Benz Patent-Motorwagen. This vehicle, patented in 1886, represented a synthesis of his prior innovations and a bold step towards practical, personal transportation. The Patent-Motorwagen's design reflected Benz's commitment to simplicity and functionality. Its chassis consisted of a lightweight yet rigid frame constructed from steel tubes. This tubular frame provided a strong foundation for the vehicle while minimizing its overall weight, a crucial consideration for maximizing performance and efficiency. The engine was strategically placed horizontally at the rear of the vehicle over the rear axle. This configuration offered several advantages, including improved weight distribution and easier access for maintenance. By positioning the engine in the rear, Benz minimized vibrations and noise in the passenger compartment, contributing to a more comfortable ride. Steering was accomplished through a complex tiller system. A centrally located tiller controlled the direction of the front wheel. This system, while unconventional by modern standards, provided precise control and maneuverability. The tiller was directly connected to the front wheel via a series of linkages, allowing the driver to steer the vehicle with relative ease. This steering mechanism allowed for a surprisingly tight turning radius, enhancing the vehicle's agility in urban environments. The engine powering the Patent-Motorwagen was a single-cylinder, four-stroke gasoline engine, a testament to Benz's mastery of internal combustion. With a displacement of 954 cubic centimeters, this engine produced approximately 2/3 of 1 horsepower at 400 revolutions per minute. While these numbers may seem modest today, they were sufficient to propel the vehicle at a top speed of around 16 kilometers per hour. The engine's low power output reflected Benz's focus on reliability and fuel efficiency, prioritizing practicality over outright performance. The engine incorporated Benz's advanced ignition system, ensuring reliable combustion and smooth operation. Power from the engine was transmitted to the rear wheels via a chain drive system. This system consisted of a chain connecting the engine's crankshaft to a sprocket on the rear axle. The chain drive provided a direct and efficient means of transferring power, minimizing energy loss and maximizing the vehicle's performance. The chain drive system was relatively simple and robust, requiring minimal maintenance and offering long-term durability. The use of a chain drive was a common practice in early automotive designs, offering a practical solution for transmitting power from the engine to the wheels. Benz faced considerable challenges in designing a vehicle that was both reliable and practical for everyday use. One of the primary obstacles was the lack of existing infrastructure to support automobile travel. Roads were often unpaved and poorly maintained, posing a significant challenge for early automobiles. Fuel was also difficult to obtain, requiring drivers to carry their own supplies or rely on pharmacies for small quantities of gasoline. The availability of spare parts and repair services was similarly limited, making it essential for early automobiles to be as reliable as possible. Benz addressed these challenges through careful engineering and meticulous attention to detail. He prioritized simplicity and robustness in his designs, minimizing the number of moving parts and using high-quality materials. He also incorporated features such as a robust suspension system and durable tires to withstand the rigors of early road conditions. Benz's commitment to reliability and practicality helped to establish the automobile as a viable mode of transportation. The patents associated with the Patent-Motorwagen were crucial in protecting Benz's intellectual property and securing his position as a pioneer in the automotive industry. These patents covered various aspects of the vehicle's design, including the engine, ignition system, steering mechanism, and overall configuration. The patents provided Benz with exclusive rights to manufacture and sell the Patent-Motorwagen, preventing competitors from copying his innovations. The patents also served as a valuable asset, attracting investors and partners who recognized the potential of Benz's invention. The specific patents related to the Patent-Motorwagen detail the unique features and innovations that distinguished it from other vehicles of the time. These patents included descriptions of the engine's design, the ignition system's operation, and the steering mechanism's configuration. The patents also covered the vehicle's overall construction, including the chassis, wheels, and bodywork. By securing these patents, Benz established his legal claim to the invention and protected his investment in research and development. Compared to contemporary vehicles developed by Daimler, the Benz Patent-Motorwagen possessed several unique features and advantages. One of the most notable differences was its three-wheel design, contrasting Daimler's initial focus on four-wheeled vehicles. This three-wheeled configuration offered several advantages, including reduced weight, improved maneuverability, and simplified construction. The three-wheel design also allowed for more compact wheelbase, making the vehicle easier to navigate in crowded urban environments. The Patent-Motorwagen's use of a steel tube frame was another distinctive feature. This lightweight yet rigid frame provided a strong foundation for the vehicle while minimizing its overall weight. Daimler's early vehicles, in contrast, often used heavier and less refined chassis designs. The steel tube frame of the Patent-Motorwagen contributed to its superior handling and fuel efficiency. The chain drive system employed in the Patent-Motorwagen also distinguished it from some of Daimler's early designs, which utilized belt drives. The chain drive provided a more direct and efficient means of transmitting power from the engine to the wheels, minimizing energy loss and maximizing performance. The chain drive system was also more durable and reliable than belt drives, requiring less maintenance and offering longer-term durability. The Patent-Motorwagen's influence on Daimler's later work on four-wheeled vehicles is undeniable. While Daimler initially focused on four-wheel designs, he eventually incorporated many of the innovations pioneered by Benz into his own vehicles. Daimler's later vehicles adopted features such as steel tube frames, chain drive systems, and advanced ignition systems, all of which were first developed and implemented by Benz. The Patent-Motorwagen served as a source of inspiration and a benchmark for Daimler and other early automotive engineers, shaping the development of the modern automobile. The contributions of Siegfried Marcus, whose earlier experiments with gasoline-powered engines laid some groundwork for the later work of both Benz and Daimler, should also be acknowledged. Marcus's work, though less commercially successful, demonstrated the potential of gasoline engines for powering vehicles. His experiments influenced the direction of automotive research and development, paving the way for the innovations of Benz and Daimler. The transition from visionary inventor to successful industrialist presented Karl Benz with a new set of formidable challenges. Building an automobile was one thing. Establishing a reliable manufacturing process and managing a growing enterprise proved an entirely different endeavor. The story of Benz and Say during the late and early 20th centuries illustrates the difficulties inherent in scaling up production of a groundbreaking and complex invention. Unlike the solitary inventor tinkering in a workshop, Benz now needed to orchestrate a complex network of suppliers, skilled laborers, and distributors. The early years of Benz and Say saw production numbers that seem almost quaint by modern standards, a reflection of the nascent nature of the automotive market and the limitations of contemporary manufacturing techniques. Each vehicle was essentially hand-built, a painstaking process that required a high degree of skill and precision. The manufacturing processes at Benz and Say relied heavily on manual labor and craftsmanship. Components were often produced in small batches by skilled artisans, using tools and techniques that had changed little over the preceding decades. The engine, for instance, involved intricate machining and assembly, demanding a level of expertise that could be acquired only through years of apprenticeship. The chassis, typically constructed from steel tubing, required careful welding and fitting to ensure structural integrity. Even the upholstery and painting were performed by hand, contributing to the overall time and expense of each vehicle. Sourcing materials presented another significant hurdle. The automotive industry, being in its infancy, lacked a well-established supply chain. Benz and Say had to rely on a patchwork of local suppliers for raw materials such as steel, rubber, and wood. Securing consistent supplies of high-quality components proved a constant struggle, often leading to delays and increased production costs. The availability of specialized parts, such as carburetors and ignition systems, was particularly problematic, requiring Benz to either manufacture them in-house or import them from distant suppliers. Training a workforce capable of producing automobiles to Benz's exacting standards was also a major undertaking. The skills required for automotive manufacturing were relatively new, demanding a departure from traditional craft-based training methods. Benz and Say established its own apprenticeship program to train young workers in the techniques of machining, assembly, and finishing. This program, while effective, was time-consuming and expensive, further adding to the challenges of scaling up production. Quality control was another critical aspect of the manufacturing process, with each vehicle being essentially hand-built. Ensuring consistency and reliability presented a formidable task. Benz implemented rigorous inspection procedures at every stage of production, from the initial machining of components to the final assembly of the vehicle. Any deviations from specified tolerances were immediately addressed, requiring rework or replacement of parts. This emphasis on quality, while essential for maintaining the reputation of Benz and SI, added to the overall cost and complexity of production. The organizational structure of Benz and SI reflected the evolving nature of the company. Initially, Benz himself oversaw every aspect of the business, from design and engineering to manufacturing and sales. As the company grew, he gradually delegated responsibility to a team of managers and engineers. The company was structured along functional lines, with separate departments for engineering, production, sales, and finance. This structure, while relatively simple, allowed for clear division of labor and accountability. Key personnel included skilled engineers who worked closely with Benz to refine his designs and improve the manufacturing process, as well as experienced managers who oversaw the day-to-day operations of the factory. Adapting his designs for mass production required Benz to make a number of significant changes. Early Patent-Motorwagens were essentially custom-built machines, each one slightly different from the others. To streamline production, Benz standardized components and simplified the assembly process. This involved designing parts that could be easily manufactured using automated machinery and developing assembly line techniques to speed up production. Benz also introduced interchangeable parts, allowing for easier repair and maintenance of vehicles. Benz and SI implemented several innovations in manufacturing techniques to improve efficiency and reduce costs. The company was among the first to use precision machining techniques to produce engine components to exacting tolerances. This allowed for improved engine performance and reliability. Benz also pioneered the use of assembly line techniques to speed up the production process. While not as sophisticated as the assembly lines later developed by Henry Ford, these early efforts represented a significant step forward in automotive manufacturing. The introduction of electric welding also improved the strength and durability of chassis components. The work of Henry Ford, particularly his development of the moving assembly line, significantly influenced Benz's later manufacturing processes. After witnessing the efficiency of Ford's production methods, Benz incorporated similar techniques into his own factory. This involved further standardization of components, automation of assembly processes, and a more systematic approach to quality control. The adoption of Ford's principles allowed Benz and SI to significantly increase production volume and reduce costs, making its vehicles more accessible to a wider market. Competition from other early automotive manufacturers, most notably Daimler, presented a constant challenge. Daimler Motor and Gesellschaft, under the leadership of Gottlieb Daimler and Wilhelm Maybach, produced high-quality vehicles that rivaled those of Benz. The two companies engaged in a fierce battle for market share, each seeking to outdo the other in terms of performance, reliability, and innovation. This competition spurred both companies to continuously improve their designs and manufacturing processes, ultimately benefiting the automotive industry as a whole. Daimler's focus on more powerful engines and sophisticated designs pushed Benz to refine his own engineering, while Benz's emphasis on practicality and affordability forced Daimler to consider the needs of a broader customer base. The rivalry between Benz and Daimler fueled innovation and accelerated the development of the automobile. The influence of figures like Frederick Winslow Taylor, whose work on scientific management revolutionized industrial production, also impacted Benz and SI. Taylor's principles of time-motion study and standardization were gradually implemented in the Benz factory, leading to increased efficiency and reduced waste. The application of scientific management techniques allowed Benz to optimize the flow of materials through the factory, reduce bottlenecks, and improve the overall productivity of his workforce. Benz's commitment to continuous improvement and his willingness to adopt new technologies and management techniques were key to the success of Benz and SI. His ability to adapt to the changing demands of the automotive market and to overcome the challenges of early automotive manufacturing cemented his place as a pioneer of the industry. The lessons learned by Benz and SI during this period laid the foundation for the mass production techniques that would later transform the automotive industry and shape the modern world. The company's early struggles and triumphs serve as a testament to the ingenuity and perseverance of Karl Benz, a visionary who not only invented the automobile, but also helped to create the industry that would revolutionize transportation. Karl Benz's legacy extends far beyond the mere invention of the automobile. It encompasses a profound transformation of transportation and a lasting influence on engineering, manufacturing, and societal norms. His pioneering spirit and innovative designs established the groundwork for the modern automotive industry, shaping the way we move and interact with the world. One of the most enduring aspects of Benz's legacy lies in his engine designs. The single-cylinder, four-stroke engine he developed for the Benz Patent-Motorwagen established a fundamental architecture that continues to resonate in internal combustion engines today. While modern engines have evolved significantly in terms of power, efficiency, and complexity, the underlying principles of the four-stroke cycle, intake, compression, combustion, and exhaust, remain central to their operation. The specific layout and design of Benz's engine, including the horizontal cylinder and the use of a carburetor for fuel delivery, influenced subsequent engine designs for decades. Gottlieb Daimler, independently pursuing similar goals, also explored the single-cylinder engine, and the eventual merger of their companies further solidified the importance of this engine configuration. The ongoing development of internal combustion engines, with advancements such as fuel injection, turbocharging, and variable valve timing, can be seen as a continuous refinement of the foundational principles established by Benz. Beyond the engine itself, Benz's innovations in chassis design, steering mechanisms, and transmission systems also had a lasting impact. His use of a lightweight tubular steel frame, a three-wheeled configuration for stability, and a rack and pinion steering system represented significant advancements in automotive engineering. The three-wheel design, while eventually superseded by four-wheeled vehicles, offered a practical solution for early automotive stability and maneuverability. The rack and pinion steering system, providing precise and responsive control, became a standard feature in automobiles and remains widely used today. His designs influenced the work of other early automotive pioneers, such as Rudolf Diesel, who sought to improve engine efficiency and develop alternative fuel sources. The evolution of chassis design, from the early tubular frames to modern monocoque structures, reflects a continuous effort to improve vehicle strength, safety, and performance, building upon the foundations laid by Benz. The specific patents held by Benz offer tangible evidence of his enduring influence. While many of the original patents have expired, the concepts and technologies they describe continue to inform modern automotive design. For example, Benz's patent for the carburetor, a device that mixes air and fuel to create a combustible mixture, laid the foundation for fuel delivery systems in internal combustion engines. The ongoing development of fuel injection systems, which offer more precise control over fuel delivery, can be seen as a direct evolution of Benz's original carburetor design. Similarly, his patents for ignition systems, cooling systems, and transmission mechanisms established fundamental principles that are still applied in modern automobiles. The modern relevance of these patents lies not only in their direct application, but also in the inspiration they provided for subsequent innovations and improvements. The work of engineers like Charles Kettering, who developed the electric starter motor, built upon Benz's pioneering work in ignition systems, further enhancing the reliability and convenience of automobiles. Benz's influence extends beyond specific inventions to encompass the broader principles of automotive engineering and manufacturing. His commitment to precision engineering, quality control, and continuous improvement set a high standard for the early automotive industry. His emphasis on reliability and durability, while challenged by the limitations of early materials and manufacturing techniques, guided his design decisions and shaped the reputation of Benz vehicles. The development of mass production techniques, pioneered by Henry Ford, drew inspiration from Benz's early efforts to streamline manufacturing processes and improve efficiency. The application of scientific management principles, such as time and motion studies, further enhanced productivity and reduced costs, enabling the mass production of affordable automobiles. The recognition and celebration of Benz's contributions are evident in numerous ways. The Mercedes-Benz Museum in Stuttgart, Germany, stands as a testament to his legacy, showcasing his inventions and tracing the history of the automobile. His name is synonymous with automotive excellence, and the Mercedes-Benz brand continues to represent innovation, quality, and performance. Engineering societies and automotive organizations regularly honor Benz as a pioneer of the industry, recognizing his profound impact on transportation and society. The ongoing research and development efforts in the automotive industry, focused on improving fuel efficiency, reducing emissions, and enhancing safety, reflect a continuous commitment to the principles established by Benz. Benz's work addressed the fundamental problem of personal mobility, offering a practical and convenient alternative to horse-drawn carriages and other forms of transportation. His unique solution, the Benz Patent-Motorwagen, combined a lightweight engine, a sturdy chassis, and a user-friendly control system to create a vehicle that was both functional and reliable. The tangible examples of his work, such as the early Benz vehicles that traversed the streets of Mannheim and Paris, demonstrated the feasibility and potential of the automobile. The innovations of Karl Benz are still relevant today. While the automotive industry has undergone tremendous transformation, the underlying principles of his designs continue to inform modern engineering practices. The enduring historical significance of Benz's work lies in his role as a visionary who not only invented the automobile, but also helped to create the industry that would revolutionize transportation and shape the modern world. His relentless pursuit of innovation, his commitment to quality, and his unwavering belief in the potential of the automobile cemented his place as a true pioneer. Karl Benz was influenced by the work of earlier engineers and inventors, such as Nikolaus Otto, who developed the four-stroke internal combustion engine. Otto's engine provided the foundation for Benz's own engine designs, inspiring him to create a lighter, more efficient, and more practical engine for automotive applications. Benz, in turn, influenced countless engineers and inventors who followed in his footsteps, including Henry Ford, whose mass production techniques transformed the automotive industry. Ford's vision of making automobiles accessible to the masses was directly inspired by Benz's pioneering work in automotive engineering and manufacturing. The significance of Karl Benz's work lies not only in his specific inventions, but also in his broader vision of a world transformed by personal mobility. He foresaw the potential of the automobile to connect people, facilitate trade, and improve the quality of life. His unwavering commitment to this vision, despite the many challenges he faced, ultimately led to the creation of a revolutionary technology that has had a profound and lasting impact on society. Benz's role extends beyond that of a mere inventor. He was a visionary who helped to shape the modern world.
We really appreciate you tuning in to this AI-powered presentation. Our goal is to push the boundaries of AI in content creation, and your input is invaluable. If there's a particular subject you'd like to see us tackle next, or if you have suggestions on how we could fine-tune our AI's creative prompts, please don't hesitate to leave your ideas in the comments section. We're excited to bring you more unique content very soon.